Hello, welcome to a 5-minute physics video of Sir Isaac Newton's 3 laws of motion, as shown here. The 3 laws are inertia, the force, mass, and acceleration relationship, and an action and reaction. The first law of motion states a body acted on by no net force moves with constant velocity and zero acceleration. The constant velocity may be zero. And here you can see that this rock, because it has no force acting upon it, is stationary and it will not feel like moving. It will not create its own force. And this one as well, which is moving with constant velocity, which is not a non-zero constant velocity, has zero acceleration and it will not change its speed. And furthermore, the second law of Newton's motion, which is perhaps the most important law, is the force-mass acceleration relationship, which states if a net external force acts on a body, the body accelerates. The direction of acceleration is the same as the direction of the net force. The net force vector is equal to the mass of the body times the acceleration of the body. Basically, the net force seen here equals the mass times the acceleration. This is very important for physics. You will use this countless times, this relationship. The third law that Sir Isaac Newton came up with states if body A exerts a force on body B, then body B exerts a force on body A. These two forces have the same magnitude but are opposite in direction. These two forces act on different bodies. This basically says that the force of A pushing on B is equal and opposite to the force B has on A. Now, all of these laws can be summed up every day in physics, where in an experiment as easy as this, with a simple near frictionless motion of a cart, a pulley with a weight attached, and this mass right here. Now, Newton's first law of inertia takes place right here, as when I pull this back, this mass here will want to resist change in motion, and therefore you will see it slide forward when I release, such as this. Now that motion right here, from this to this, is this mass's tendency to resist a change in motion, and therefore it wanted to continue moving at the speed it was moving while it was on the cart, and therefore it slid forward. Now Newton's second law, F equals ma, force equals mass times acceleration, can best be seen right here as this mass of about 200 grams, or 0.2 kilograms, the force of gravity is acting on this mass right now. The only thing keeping it up is this string. So with the acceleration of gravity being roughly 9.81 meters per second squared, and the force of 0.2 kilograms, it's a relatively easy problem to solve to find the magnitude of the force. But as you can see, the force of this as it falls is enough to pull this cart, and therefore that is a good example of F equals ma. Now the third law comes into place at this junction right here, where this cart, because it has a magnitude and a mass, and therefore it has a force, and this force acts upon this junction right here, which is part of the pulley, and it stops. The pulley stops the cart's motion because the force here is this part of the pulley applies a force equal and opposite to the force that the cart applies on it when it stops right there. And that together is a good example of all of Newton's 3 laws.